Okay, you're back with me, and I hope you didn't go anywhere for any amount of time because I was sitting here and waiting that entire time for you to come back, ready to teach you about the halogen scrubber. Okay, so this was the next piece that we said we would talk about, a halogen scrubber. So what exactly is a scrubber? What does it do? And maybe what's a halogen? If you've not taken Chemistry 151 and 152, you might not know what a halogen is. So I'm not going to take anything for granted, and we're going to go through and we're going to talk about the location of the halogens, where you can find them, what are the halogens from the periodic chart, and then why these things are so important. All right, so halogen scrubber. That's going to be the lesson for this video. So if I go back to this schematic, and this schematic is, again, the one that we are constantly looking at over and over and over, the area that I want to focus in on is the halogen scrubber, which in this diagram is listed as number 10. And the halogen scrubber is actually this piece right here. All right? Okay. The location of this halogen scrubber is in between the dehumidifier, which we've talked about before, and the NDIR detector. All right, so there's got to be a reason that it's here. Okay, and we'll talk about that reason. But this is conveniently located between the dehumidifier and the detector. So my sample has to go through the dehumidifier first, which will remove extra moisture. And then the sample is going to go through the halogen scrubber before it reaches the NDIR detector. Okay, so let's first talk about halogen. What is a halogen and where can I find the halogens? So on this slide, over on the right-hand side, you're going to see the area that has the halogens. And it's already circled in red. Right here you go. These are what we call the halogens on the periodic table. Fluorine, chlorine, bromine, iodine, astatine. Those are the halogens. And for us, in particular, we really mainly are worried with fluorine, chlorine, and bromine. Now, of course, there's others, right? I mean, they're listed right there. There's two others. But it seems like if I have to put more commonality on some of these, ones that are showing up that have a higher occurrence, it's fluorine, chlorine, and bromine. So that is the location that we're talking about, and those are the particular elements that we are concerned with. And the reason is because the halogens love to slowly destroy the NDIR detector. All right. These halogens are corrosive. And corrosive, many of them mean they love to react with metal. And they begin to eat and destroy the metal. And that metal could be found in the NDIR detector. So I have to ensure that none of the halogens make their way to the detector. And the way that I do that is I install a halogen scrubber. And the halogen scrubber removes the halogens that could be present in my sample before it reaches the detector. Okay? Now, how does the halogen scrubber work? Well, I told you that these halogens love metal. And we do not want it to react with the metal that's going to be found in my detector. So the halogen scrubber, literally, for the most part, is made up of copper mesh. That's it, folks. Some copper. Because that's a metal. And if I allow my halogens to react with that metal, then I could go ahead and remove them from the picture because they're distracted before they even reach the detector end of my instrument. All right? So that copper is very important, and that copper is playing a role. And the copper is basically bait. The copper is present in the scrubber, so that way my halogens can react with the copper and not make it any further into my instrument and into my detector. So over a course of time, this halogen scrubber does need to be replaced. And the reason is because there's only so much copper. Once that copper is reacted, once the copper has prevented a certain amount of halogen to go through, well, there's no more copper left, or there's very little of it. So I want to make sure that my halogen scrubber stays fresh for all of the samples that I'm injecting into it throughout the weeks and throughout the months. And there's a very easy way to determine if your scrubber needs to be replaced or not. Okay? So, no to halogens. They can degrade the NDIR detector. They do that because they're corrosive and they will eat those metals. And if I'm eating the metal in my detector, it's probably not going to last a very long amount of time before I'm going to have to fork out another $2,000 to replace that detector with. And nobody wants to do that, right? Okay, so where's this halogen scrubber? Well, we talked about in the schematic where it is, but where is it in the instrument? Because this is a piece that has to be exchanged, maybe depending on your samples, on a regular basis, the halogen scrubber has to kind of be upfront and personal with you. So what you're seeing on the screen right now is the front part of the TOC with the door open. And over here to the right-hand side, you are going to see a fairly large, what I would call column or tube, cylindrical in nature. And that will have something coppery looking on the inside of it. There is my halogen scrubber. All right. Now that halogen scrubber is meant to be up front, is meant to be easily accessible, because this is something that you have to change maybe again on a regular basis, depending on the types of samples that you're running and that you're analyzing. Again, I can change the picture on you. You can maybe see this a little bit better. It's just from a different angle. I've zoomed in a little bit. This is actually the same picture that we used to talk about this piece, right? And that piece was called the humidifier. And the halogen scrubber is actually right here in front of it. It's kind of mounted on its own brackets, and there's a tube, if you've noticed, up here to the top that leads, and a tube down here at the bottom that leads. So this makes sense. If my sample is supposed to go through the halogen scrubber and out the other end into the detector, then I know there's going to be an entry and I know that there's going to be an exit. And if I take a look at the exit and I take a look at the entry point, that also means that this scrubber is going to be very important as far as which way is front and which way is back. So very often you will see this thing called flow, and there'll be an arrow on it, all right? And it will tell you which way that you are supposed to point this halogen scrubber in. So you can't just flip it around any way that you want to flip it around. It's not universal, so to speak. You really do want to keep it in the same location, keep it in the same flow, keep it in the same direction, because that's going to be very important later on when you begin to determine if you need to replace this thing or not. All right, so before I give you those hints and tips, to loosen this up, it's very easy to do. You take the entry and the exit point and you just basically unclamp it. That's really all that you have to do here. So you unclamp the tubing and this whole entire piece will be removed, and you will purchase a new halogen scrubber, and the new halogen scrubber goes back on inside of the holders and it snaps back into place, and you just reconnect the tubing again. Once more, that new halogen scrubber will have a flow direction on it, and you want to make sure that you are installing it in the proper orientation or the proper direction. All right, so that's all there is to replacing a halogen scrubber. Again, it's not rocket science here. This is something that could be commonly replaced. It's something that I have to have easy access to, and literally the only thing I do is unsnap the top, unsnap the bottom, remove this piece fully, put in my new one, and connect the two tubing lines again. That's it, folks. That's all that we have to do to replace a halogen scrubber. So please do not call someone in from Shimatsu to do this for you. Anyone can do it. And then after you replace that piece, you just want to make sure that the machine's working properly again. Make sure and confirm that you're getting good quality data. And then if you do, away you go. You can start your analysis all over again. How much does this thing cost, right? That's always a question that we also have. The halogen scrubbers typically cost around $128, okay? So $128, $130. For us, it will last a couple of years before we will have to go and replace it. For an environmental laboratory, you could be looking at a couple of weeks or maybe a month before you have to replace that halogen scrubber. But that is something that has to be replaced, and you have to constantly look at it to make sure that it's still good and that it's still doing its job. Notice also in this picture, one of the reasons I like for you to see it is because the label in the front will have the arrow clearly depicted on it. So you know which end is up, literally, okay? So you'll know the flow direction. You'll know how to install this in the proper orientation. You just want to make sure that it matches the flow direction of the last one that you took out. Shimatsu's, those could be a little bit different as far as how they're made and the way the lines are fed. So that really is based on the instrument manufacturer. It's not really a universal direction like that arrow always needs to be pointed up. Not necessarily, okay? So that really is just based on what type of TOC instrument that you are using in your laboratory at that particular time. I do have a video that shows you how to remove this. I mean, it's very simple, but I can still show you. Okay, so here's the front of the TOC instrument, and we're just going to kind of slowly play this. You're going to see them open up the door, and when they open the door up, they're going to zoom in on the halogen scrubber area, which is down there in the bottom right-hand corner. The tubing line gets disconnected from the top and the bottom, and then this entire halogen scrubber gets removed, and the new scrubber is put into that position, and then the tubing line again gets connected to the bottom and to the top. Those metal clamps, they are going to be quite stubborn when you begin to use them, but the reason is because that helps the tubing to stay in place. You don't want your tubing to come loose, especially through the middle of an analysis. So those little bitty metal clamps that you saw there at the ends and at the tops of that halogen scrubber, let me kind of zoom in on that picture again so you can see them. So right here at the bottom, and then up here at the top, it's on the black kind of piece of rubber that sits up on the top. Those little metal clamps, they are going to be stubborn and they're going to hurt sometimes. You are going to have to squeeze those in to loosen that tubing up. And depending on how old those metal clamps are, they might do their job really, really, really well. And it's going to be very difficult for you to get the tubing out of that clamp, but it is meant to do that. You do not want any leaks around those areas. So that's all there is with exchanging a halogen scrubber. Now, I told you that during this time, there's kind of a key on what you need to be looking for in your halogen scrubber. You know, how do I know if it's time to replace that halogen scrubber or if I'm just wasting money? Well, some people are going to waste the money. Some people are going to replace the halogen scrubber on a routine basis over and over and over, whether or not they need it. And here is kind of my guideline to you about the scrubber. Okay, so here's the scrubber, and in our instrument, I believe that our arrow points up, just like this, and my flow rate comes in from the bottom, and it comes out of the top. So over time, what will happen is that my sample will go into this halogen scrubber, and this halogen scrubber is going to go through some copper mesh, right? And that copper is going to be like a shiny copper penny. It's going to be very shiny. It will be very bright. You'll see it. It will look like copper, okay? And over time, what begins to happen is that my sample begins to react with the copper. Now, what in my sample? It's the halogens, my fluorine, chlorine, bromine, and so forth. Those are the pieces that begin to react with this copper. Over time, when that process begins to happen, this copper will slowly start to tarnish, and I will start to see this copper start to go blackish or grayish. It won't be coppery looking anymore, okay? And I can actually track it. Normally what happens here, and this is why the direction is very important, is that in the beginning, my darker area where it begins to tarnish on me will happen here in the bottom. And over time, as that halogen scrubber sits in the machine, and as I process samples over and over, the halogens will work themselves up further and further and further into the halogen scrubber. So I'm going to see more of a darker area that takes place every single time that I use this scrubber when halogens are in the picture. So what I want to do is that I want to remove the halogen scrubber and I want to replace it with a new one before that black tarnish area makes its way up here at the top. Okay, I'm talking about a quarter of the way. If I start to see a quarter of the way that this copper is not as bright and coppery anymore, then that's a very good sign that I just need to go ahead and remove it, replace it with a new one, because that is a sign that halogen could be escaping my scrubber and making its way into the NdIr detector. And that's something that I don't want, okay? So again, halogens are bad for this instrument. Halogens are bad because halogens will make its way into the detector and eat the metal that's located in the detector. So I want it to eat the copper here before it makes its way to the detector, and it literally kind of neutralizes it out. I don't have to worry with it, and that's the whole point of a scrubber. Anytime we scrub something, we're removing it. We're getting rid of it. You scrub your hands, and the reason that you're scrubbing your hands with soap and water is to get rid of all the germs and everything else that's nasty on your hands, right? That's the whole reason that we do it. The same thing's happening here. It's a halogen scrubber. So we are removing the halogens that's going to be found on my sample. Now, let's talk about why those halogens are there in the first place. Okay, we've went through this whole discussion about halogens are bad, halogens can't make it to the detector, halogens react with the copper, it removes them from the sample so I don't have to worry. Well, why would it be in there in the first place? That doesn't make any sense, right? Okay, so let's say that I bring in some drinking water. And let's say I'm working with an environmental lab, and that drinking water sample has to be tested. Well, that drinking water hopefully is pretty safe, right? It's hopefully pretty clean. Well, that's true. But that drinking water has also been treated with decontaminant, meaning that there could be some nasty crud in the raw water source, and they have to do what they call halogenate that sample to kill all of that nasty out. So, for instance, they will fluorinate your water. Ding, 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 ding. There's your halogen, okay? Or they could chlorinate the water. Ding, 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 ding. There's your halogen again. And that fluorination or chlorination or bromination step, which is meant to give you clean drinking water to kill out any kind of nasty bacteria that might be there before you get it through your tap, all of that is still there. All of it is still in your drinking water. If I run drinking water on a machine, it's going to tell me that fluorine is present, chlorine is present, bromine could be present. And all of that is a halogen, and that halogen cannot make its way into the detector. So it has to go through the halogen scrubber, and it removes all of that out of there. All right, it's very, very important. Those halogens have to be removed. Well, that's drinking water. Well, what about wastewater? Same deal, same concept. Well, what about pharmaceutical grade water? It should be ultra pure, right? The answer is yes, But if there's any traces of these halogens, then this scrubber will remove them for the same reason and the same purpose, right? I mean, that water source had to come from somewhere. And hopefully these are extremely low levels. And these halogens will not be present in ultra pure water, but the pharmaceutical company will still have to check it. They'll still have to check to make sure it is ultra pure for them before they use it. So that halogen scrubber hopefully would last a little bit longer because I'm injecting cleaner samples maybe in the beginning. And if I can inject clean samples in the beginning that has very minimal amount of halogen, then all of a sudden this is a better story and a better scenario for me. I don't have to replace that scrubber as much. Okay, if I was working at CFPUA and I was processing drinking water though, I know I'm going to have these halogens there. I know that they're going to be present, and therefore my scrubber will turn and tarnish. And that's something I constantly want to look for and replace when I can. If not, it's going to cost me a lot of money down the road by the time that I get there, just because I had no clue what the scrubber was doing or why the scrubber was there in the first place or what to look for when the scrubber is concerned. But now you know, and knowing is half the battle, right? As far as the chemical processing is concerned, think about some of those. We said that we could use this instrument to test for maybe hydrochloric acid impurity. Hydrochloric acid. I see chlorine, HCl, hydrobromic acid, HBr, hydrofluoric acid, HF. So of course, all of those will also be involved, and that's something that I have to pay special consideration to. So those types of materials will probably eat the halogen scrubber a little bit faster and a little bit quicker than some of the environmental samples that we might see. But again, it just really depends on what you're running in a lab. But you'll know what you need to know by looking for the dark, tarnished areas. Okay? All right, so that's the story with the halogen scrubber, and I'm sticking to it. So in the next video, what we need to do is we need to go back to the schematic, and we need to take a look at what else that is on the schematic that we haven't talked about yet, and I'll give you a couple of options. We've not talked about this purified water trap. We've also not talked about this CO2 absorber. And we've also not talked about something else that is not really listed in this schematic full-blown, and that's this dilution water. Where's that coming from and where's that located? So those are kind of the remaining pieces that we need to discuss and we need to talk about. And finally, almost forgot one, this poor little filter down here at the very end. So a couple of more things that are out there. We still not finished with the TOC instrument yet. And when we come back, we'll pick up with some of these other pieces and parts that's very important, that gets the machine to do its job, and talk about the reason that they're there, where to find them, how to maintain them, how to troubleshoot them, so that way I can ensure that my instrument is staying good from the time I start it to the time I end it.